Hello friends, now let us know what are touching circles. Two circles are said to touch each other if they have only one point of contact. Suppose O is the center of this circle, O dash is the center of this circle. These two circles are touching each other at this point P. So we can say that these two circles are touching each other externally and they have only one point of contact. So two circles, if they have only one common point, they are said to be touching circles, and these two are the two circles touching each other externally. Then other one is one circle and this is the point of contact, another circle. This is the center. O is the center of the larger circle and O dash is the center of the smaller circle, and these two circles have only one common point. So, and these two are touching each other internally. So there are two cases. One is two circles when they touch each other externally. Other one is when two circles touch each other internally. The point of contact is they will have only one point of contact. Now let us know what are common tangents. What are common tangents? A tangent is said to be a common tangent if the tangent touches two circles. A tangent touches two circles. Let us have, this is one circle, this is another circle. This is a line touching this circle at P and this circle at Q. Let me name it as L1. L1 is touching these two circles with center O and O dash at P and Q. So this is said to be the common tangent. Okay? And there are two types of common tangents. Let me explain you what are they. There are two types of common tangents. One is direct common tangent and other one is transverse common tangents. Let me explain you what are direct common tangents and what are transverse common tangents. Okay? Let me explain you. Suppose this is one circle with center O. This is another circle with center O dash. Then if the tangent is on the same side of the two circles, or this is the tangent, common tangent of both the circles. The two circles are below the line. Same way, let me draw one more common tangent to these two circles, and these two circles, this is L1, L2. Both the circles are above this line L2, and here both the circles are below this line L1. And such type of tangents are said to be direct common tangents. And what are transverse common tangents? Okay? Same way, let me name it as P dash, or the centers of two circles. Let me draw a line. This is a tangent to this circle and also the tangent to this circle. You see? Let me name it as L3. This is the tangent to both the circles. That's why it's a common tangent. This circle is below the line and this circle is above. That means both the circles are on the both sides of the line. Such type of tangents are said to be transverse common tangents. Same way, let me draw one more tangent touching both the circles. circles. You see, to this, this is L3, L4, line tangent L4, circle with center P is this side, circle with center P dash is the other side of this L4. So these are transverse common tangents. So what did you understand? Direct common tangent means that both the tangent having both the circle on one side of it. Transverse common tangent means the circle will be on either side of it. Okay? Now, let us have a theorem related to this. In the form of property, if two circles touch each other externally or internally, their point of contact lies on the line segment joining the centers. Joining the centers. Let me draw this. These two circles are touching each other externally. Let it be O, center O dash. This is O dash. When we join these two, this is the point of contact. P lies on O dash. That is the property. Let us draw a line through P. Through P. This line L is touching the circle with center O at a point P. And also this line is touching the circle with center O dash at the same point. How can we say that this point P lies on the line segment joining these two centers? We know that the angle between the tangent and the radius through the point of contact are perpendicular to each other. So here, if I name it as A, angle OPA is 90 degree. Same way, angle O dash PA is also 90 degree. So angle OPA plus angle O dash PA equal to 90 degree plus 90 degree equal to 180 degree. That means angle OPO dash is 180 degree. That means OPO dash is a straight line. OPO dash is a straight line means P lies on the line joining on the line segment joining the centers of two circles. Same way, when two circles touch each other internally also, how? Suppose O is the center of the outer circle, O dash is the center of the inner circle. When we join these two and produce them, and this is the line joining the center to the point of contact. And if it is L, let me name it as A here. O is the center of the outer circle. P is the point of contact of this tangent and the radius. So angle OPA is 90 degree. Same way, O dash is the center of the smaller circle, and to this smaller circle also L is the tangent. So angle O dash PA is also equal to 90 degree. Angle OPA is equal to angle O dash PA. What does it mean? OPA and angle O dash PA both equal to 90 degree. Both are equal to 90 degree each. That means O dash P is a straight line. That means P lies on the line joining the centers O dash when it is produced. When it is produced. Clear? And also you see, if R1 is the radius of the outer circle, R2 is the radius of inner circle, then the distance from the two centers is R1 plus R2. When two circles touch each other externally, then the distance between the two centers is the sum of their radii. And in this case, you see, OP is R1, O'P is R2. And here the distance between two radii is, here O or dash is R1 minus R2. That means when two circles touch each other internally, the distance from their centers is the difference of their radii. Whereas when two circles touch each other externally, the distance between their radii is, distance between their centers is the sum of the radii of their circles. I believe you understood it. Please don't forget to subscribe the channel. Thank you.